Okay, for number 22, I'm given a few things and I know I need to prove something, and it's also giving me a little diagram there, a little picture. So I know that angles 1 and 3 are complementary, and then angles 2 and 4 are complementary. And it wants me to prove that 1 and 4 are somehow the same angle. Well, let's kind of start here. I'm going to go ahead and start by writing out my givens every single time. That's how I start. So I'm going to say angles 1 and 3 are complementary. I'm just going to say complement. And then I also know that 2 and 4 are complementary. Okay, so that was just given to me. All right, so my step two here isn't really going to have anything to do with my given. I'm just going to kind of look at things here. Something that sticks out to me, it's very obvious, is that angles 2 and 3 are vertical angles. Those are angles right across from each other, formed by those two intersecting lines. So I'm just going to say that I know that for starting. 2 and 3 are vertical angles. And I know that just because of the definition of a vertical angle. For my step 3, I can conclude if I know two angles are vertical angles, I can conclude that those are congruent. So my step 3 is just going to be to do that. So angle 2 and 3 are congruent because I know they're vertical angles. That actually comes from the vertical angle congruency theorem. Okay, and so that came from my step 2. I'm going to draw a little arrow. And then for my step 4, I'm trying to prove that 1 and 4 are the same angle. Those are congruent angles. Well, I'm going to start by saying that angles 3 and 4 are complementary angles. And I know that because it says that I know that angles 2 and 4 are complementary. So right here at this green dot on the left, angles 2 and 4 are complementary, but 2 and 3 are the same measure. So I can say that 3 and 4 are complementary. Because I know 2 and 4 are complementary, and I know that 2 is the same angle as 3, so I can say 3 and 4 are complementary. And I know that. That comes from my congruent complements theorem, but the converse of it. Okay, so I know it came from the converse of the congruent complements theorem because I came from the fact that two angles were complementary and then something was congruent to something else, and then I went all the way to something being complementary again. If I was going from complementary to congruent, that would just be the congruent complements theorem, but I used the converse of it because I went from congruent to complementary. So that came from step 1, some of my given in step 1, and it also came from my step 3. All right, so I have one more step here actually, and it's going to be step 5. I'm going to put it right down here in the corner kind of. So if I know that angles 3 and 4 are complementary and 1 and 3 are complementary, the angle that I have in common there is angle 3. So angles 1 and 4 have to be the same measure. So angles 1 and 4 are congruent. And I know that from my congruent complements theorem. So unlike step 4, I'm actually using the just plain old congruent complements theorem, because I'm eventually getting to the fact that two things are congruent. If I was eventually getting to the fact that two things were complementary, like I did in step 4, that's when I use the converse. So step 5, this is the congruent complements theorem. And that came from my given and also my step 4. And I'm done.